important part of the array discussion, and it is on the whiteboard, so the recorder could not have recorded that anyway. Okay, but the most important part about this is coffee mug 0 of box A has absolutely nothing to do with coffee mug 0 of box B. Okay, so those two coffee mugs are completely independent. They're just sold to be 0, inside the box. But other than that, they have nothing in common. But to answer your question, why we're counting from 0, the true reasoning, the actual reasoning of that, you can understand it in cisp300 assembly language programming. But to give you an idea, this coffee mug here, coffee mug 0, is at an offset of 0 distance from this edge of the box. That is basically the reason why it is numbered 0 instead of 1. Okay. But it is counterintuitive, at least initially, to most people, because we like to count 1, 2, 3, 4, and so on. But in programming, when we're dealing with arrays, we always count from 0, 0, 1, 2, and so on. Right? Okay. So we have the concept of a box. Inside the box, we have coffee mugs. And then the coffee mugs inside the box do not have names, they have numbers instead. Okay, the outside of the box has a name. Okay, so let's see how we can refer to a particular coffee mug. Let's say we want to refer to this coffee mug here, coffee mug number 2 of box A. What is the notation to refer to that? Now, yep, go ahead.
Is it a bracket to n bracket?
Yep. So we know that there are 2 components that we need. Your answer is absolutely correct. We have 2 components that we need in order to identify a particular coffee mug. I'm going to point it out here because some people may not be able to read down here. Okay, so we know that the name of the box is important. Okay, we also know the number on the coffee mug itself is also important. So we know that A has to be there somewhere. 2 has to be there somewhere as well. In most programming languages, we use the square bracket around the number in order to identify, okay, which part is the name of the box. Outside the square bracket, what is the actual number of the coffee mug inside the box? It's 2 in this case. So one easy way for you guys to remember is the square bracket symbol itself kind of looks like a box, right? And A is the name of the box itself, that's why it's on the outside of the box. And 2 refers to the number of a coffee mug inside the box, and that's why it's inside the square brackets. So that's one kind of quick and easy way to remember, which part goes outside, which part goes inside. For those of you who have taken classes where you use vectors in math, it is basically the same thing as A with a subscript 2 in those classes. Okay, but if you have not taken a class like that, that's okay. We just need to use A square bracket 2 close bracket to represent it. Are we doing okay so far with the square bracket notation? Now, what is interesting about the square bracket notation is inside the square bracket can be any expression that gives you a valid number. In other words, it doesn't have to be constant 2. It can be a huge, long expression, this long as that expression evaluates, in this case, to 0, 1, or 2, we are good. Okay? Now keep that in mind. Okay? Keep that in mind. It will be useful later on. That's one notation. The second notation is the bar A bar notation. You put the name inside the bar and the bar, you put 2 bars around it. This represents the number of elements inside an array, or in this case, the number of coffee mugs inside the box. I chose to use the bar A bar notation because it's kind of like measuring the width of something. Okay, so you can use that to help remind you it is not the absolute value of an array, it is the number of items in an array. Those are the 2 concepts. Yep.
So if you were to use 1 for the for A bar, do we just put 1 bar? Or?
No, it has to be two bars. So it has to be bar A bar. Okay. Only in this class. Okay, that's pseudocode only. Okay. Those are the 2 operators that we are defining in this class that is new because of the concept of arrays. Yep.
So the brackets, the A, that represents how many mugs are in the box.
You mean the bar?
Is that, yeah.
Yeah, bar A bar represents the number of elements in an array, which in this case would be the number of coffee mugs inside the box. You can see that in some cases when you buy something by the case, On the outside, it will tell you how many items are inside the case, right? It's basically that. Yep.
So it's not magnitude, it's math.
It's not magnitude, it's not absolute value. Which uses the same symbol, but in this case it's applied to an array and not a single value. Yeah, I use symbols in a different way, differently from a math class. So it can be a little confusing sometimes.
So would that be 3 copy mugs, or would it be 0, 1, 2?
In this case, it will be bar A bar is 3 in this case. So bar B bar is going to be 2 because there are only 2 coffee mugs in box B. Okay. So are there any questions about the 2 notations? One would be the square bracket notation, so you can choose a particular coffee mug inside the box. And then the second one is the bar A bar notation, which means the number of items inside the box. Those are the only 2 things that we need to, that is additional to stuff that we have already understood up to this point. So what we'll do next is we're going to take a look at this algorithm and trace it to find out what it does. Let's do that with LibreOffice.
What is our goal with arrays? What is our goal with arrays?
You will see when I trace it, you will understand why arrays are flexible and why it is useful. Yep.
In an algorithm, do you have to initialize the bar B bar before you?
No, well, in a trace, I will have to give you the number of items in an array ahead of time, so that way okay, this column to this column is array A, so you will know ahead of time how many items are in the array. Good question. But let's go ahead and do a trace that will also help answer your questions. Both questions. All right, so we'll use calc and we get started with the algorithm. This is actually the, okay, we need 2 windows, one to do the trace and the other one to show the algorithm itself. So we'll go ahead and start with m gets a bracket 0. I gets 1, while I is less than bar A bar, do if m is less than a bracket I, then m gets a bracket I, and if I gets I plus 1, and while. Right. One more notation. There we go. All right, so now we can use another sheet to trace this particular algorithm. We have the usual comments because we do have 2 conditions to evaluate, one on line 3 and one on line 4. We have line number, we have m as a usual variable, we have I as a usual variable, and then we have A. A is not usual in the sense that it does not use a single column. Depending on how many elements it has, each element takes up 1 column. If it has 4 elements, it's going to take up 4 columns. So let's go ahead and just make it so that this time we have 4 columns. This is just the way I denote the columns, so that in this case, column E is A bracket 0, column F is A bracket 1, column G is A bracket 2, and column H is A bracket 3. Just to make sure that we understand that these 4 columns all belong to variable A or array A, I can merge the cells. Okay? To merge the cells in LibreOffice, you go to Format, you go to Merge Cells, and then you just click Merge Cells. It is grayed out at this point because it is already merged, so you cannot re-merge it since it's already merged. Okay. And we'll just go ahead and resize the columns a little bit, make it easy to read, and then we'll be ready to trace it. All right, so in this case, I have to give you, starting values in the array because we're trying to find the maximum of the values in the array. So we'll go ahead and just pick some values here. We'll do a 7 to 4, and maybe 11 over here. The other two columns do not start with any specific value because they will be initialized by the algorithm itself. So this becomes my precondition. Are there any questions at this point? What is bar A bar in this case?
1.
Yep, bar A bar is 4 because we have exactly 4 elements in array A. Now it is important to remember that each element has its own column because the value of each element in an array is independent from anywhere else, from anything else in the entire algorithm. Are we doing okay so far with this initial state or precondition? Okay. Now we start with line 1. Line 1 is an assignment statement. The left-hand side is pretty easy. It is just variable m in this case. The right-hand side is a bracket 0. A bracket 0 has a value of what? 7. That's right. Okay. So that means m is initialized to 7. On line 2, I, which is a regular variable, is initialized to 0. So we just put a 0 here.
Isn't it 1?
Oh, 1, sorry. Yep. Go. Okay, and then we move on to line 3. And line 3 has a condition to evaluate. Do we have any questions at this point about line 1 particularly? Questions? Okay. So on line 3, we're going to evaluate the expression, which is I is less than bar A bar. What is bar A bar? 4. And I has a value of 1. 1 is less than 4 is true. We go to line 4. And line 4 is going to compare m with a bracket I. So before we can do this comparison, we have to find out exactly what is the value of I. I has a value of 1, right? So a bracket I refers to a bracket 1 because the value of the expression inside the square bracket will tell us which element we want to access in this case. In this case, the expression is I has a value of 1, so a bracket I is referring to a bracket 1. A bracket 1 has a value of 2. So is 7 less than true? 7 less than 2 is true or false? It is false. Okay. So this expression is false. And where do we go?
Line 7.
Line 7. On line 7, we're just adding 1 to I. I goes from 1 to 2. And then we go back to line 3. I is now 2. 2 is less than 4 is true. We go back to line 4. This time we're comparing m to a bracket I again. But you know what? I has changed. I is now 2. So a bracket I is not referring to a bracket 1 anymore. It is now referring to a bracket 2. And a bracket 2 has a value of 4. 7 is less than 4 is false. Okay. But it is important to notice that the comparison of row 7 and row 10 in the trace, they may look the same to you, when you look at whether it's true or false, but we are actually comparing to different elements in the array because I has changed. Yep.
So I becomes the variable that's in the brackets up top instead of actually dot.
That is correct. We are using I to tell us which element in the array we're trying to access. Yep. Okay. All right, so if the condition of line 4 is false, we go to line 7. Line 7 is adding 1 to I again. I goes from 2 to 3. We go back to line 3. I is now 3. 3 is less than 4. It's still true. We go to line 4. This time we're comparing m to a bracket 3 because I currently has a value of 3. A bracket 3 is column H. Column H has a value of 11. 7 is less than 11 is true. Okay, so this is now true. So that means we have to go to line 5. On line 5, we have an assignment statement. The right-hand side is a bracket I. A bracket I is a bracket 3 because I has a value of 3. A bracket 3 has a value of 11. So the right-hand side in this case is 11. We copy the value of the right-hand side, which is 11, to the left-hand side. The left-hand side is just variable m in this case. So we update m, which is column C, to 11. And then we are done with the entire then branch of the conditional statement. We continue execution on line 7, and we increment I from 3 to 4. We go back to line 3. I is now 4, RA bar is 4 as well. 4 is less than 4 is false. So we get out of the loop, and we get to post. So this is how we can use a loop combined with the concept of array indexing in order to find the maximum in an array, and the size of the array can be any number. You can have a trivial case where the array only has one element. Okay? In that case, we don't have to go through a single iteration. You can also have an array of 30,000 elements,
Okay.
and it will take a long time to trace, but it does not change the algorithm at all. Okay? It would just be a lot longer because you have A bracket 0 all the way to A bracket 29,999, but it doesn't change the structure of the code at all. Yep.
Flow sheet.
Flow sheet. Right. It's interesting, somebody just left. And we are only about half an hour into the class. All right. So do we have any questions about this trace? Any row in the trace that you want me to go over, or anything that you want me to explain?
Yeah, 25th, right? Sorry.
Today is the 25th. Yep. Just label that column. Thank you. Yep, go ahead. It is implied in the trace because when you look at A, it has like 4 columns allocated to it.
But not here, the trace, the algorithm, would you even see how many items are in the array or no?
Could you ask that question again?
Because if you look at the algorithm, there isn't any set number of items in the array. Would you ever see that in the algorithm? Or
We do not have any specific code to change the size of an array in the algorithm. That is true with some programming languages where the size of an array is determined when you declare the array. So you cannot change the size of an array dynamically. Like in C, C++, with those two programming languages, when you declare an array in an algorithm, let's say, okay, I need an array of this many elements, that basically sets the size of the array. You cannot change it afterwards.
but how would you set it? Like, if you only want 4 objects, 4 items in the array, where would you set it?
The number of items in the array.
How do you declare that?
In this class, we don't have any specific declaration, so I just give you the trace, or the initial condition of the trace will tell you ahead of time, how many elements we're dealing with. So you have to actually look at the trace, not the algorithm itself, but when you look at the trace, in this case, we have these 4 columns allocated to array A, and that's how you know that array A has 4 elements. But we can't really change it, while we are running the algorithm.
If you were to look at real code, then where would
Right.
you see it then?
If you look at real code, then there's a declaration somewhere to define the array, and the declaration itself will basically tell you the size of the array. But there's no equivalence, when I use the pseudocode representation here. I think I understand what your question is. In C, what you do is, if you want to have an array of 4 integers, then you basically say, int A bracket 4, semicolon. So this line is basically doing 2 things. It is defining the array, it's also declaring the array. In this case, it's declaring that array A is an array of 4 integers. So that's how you do it in an actual programming language. But in pseudocode, in this particular pseudocode, I don't have any mechanism to do
That's what I wanted.
that. Okay. Any other questions before we move on to the next example of using arrays? No questions? All right, so let's go ahead and take a look at the next one. All right, the next one is something that you have seen already in the exam, but I'm going to use it, reuse some of that logic as an example to use an array. So in this case, we have I gets initialized to guess, well, let's put a 0 here. And then we have A bracket 0. Oops, A bracket 0, getting a value of 1, while I is less than bar A bar minus 1. The following. A bracket I plus 1 gets A bracket I plus I plus I plus 1. In fact, I can change this one to a 0 and it will still work. I gets this 1. While how many people kind of remember something like this in exam 1? Okay, very good. I'm kind of glad that you guys still remember the questions after the exam.
Or at least this one.
So the question is, what do you think this code is going to do? Okay. So now we have comments, line number. We have only one regular variable I, and then we have array A. Array A, let's say we have 4 elements again this time. So we have A bracket 0, 1, 2, 3. And this time I have everything being unknown because even the array is getting initialized by the pseudocode. Alright, I'm just reformatting everything so they look right. And this is my precondition. Alright. Do we have any questions before we get started with the trace itself? No questions? Okay. So let's go ahead and get started trace. On line 1, I gets a value of 0. On line 2, A bracket 0 has a value of 0 as well. Okay. On line 3, we have the comparison, which is similar to what we usually do, what we did before, except there's a little twist here because instead of comparing just to bar A bar, I'm now comparing to bar A bar minus 1, okay, which is not a big deal. Bar A bar is 4 because I have 4 elements allocated to array A. 4 minus 1 is 3. I has a value of 0. 0 is less than 3 is true. Okay. Any questions about this step on line 3?
Since you don't know it, it just equals to 0. Oh, no. I got it.
Yeah. Or, I can just make this more explicit. The array A has 4 elements. So once again, go to Format, Merge, and then merge cells. That's how we can merge 4 cells into 1. And then this time we move on to line 4. Line 4 looks awfully confusing, right? Well, what type of statement are we dealing with here on line 4?
And assignment statement.
It's an assignment statement. So what 2 steps do we have with assignment statements do we have to perform?
Evaluate the right-hand side. Assign that value to the left-hand side.
Yep, so let's evaluate the right-hand side first, okay? All right, the right-hand side is A bracket I plus I plus I plus 1. What exactly is the value of I at this point?
0.
0. What is the value of A bracket 0?
0.
It is also 0, okay. So we have 0 plus 0 plus 0 plus 1. Wow, it is 1 on the right-hand side, okay? The big question is, what are we doing with that value? We want to update the left-hand side with that. But the left-hand side is no longer just a simple variable. It is now A bracket I plus 1. It's not even just A bracket I. It is A bracket I plus 1. Okay, so what do? Well, when you have parentheses and brackets, you have to evaluate what is inside first, and then you perform the operation outside of the parentheses, right? So in this case, we do exactly the same thing. We have to find out what is I plus 1 first. I is 0, I plus 1 is 1. So we have a value of 1 inside the square brackets on the left-hand side. Is that making any sense? So that means the left-hand side is really the same thing as A bracket 1. Can we change A bracket 1? Does it have a column so I can change it?
Yes,
Absolutely. Which column are we referring to? Column E, that's right. So that means column E is updated to a value of 1 using line 4. Do we have any questions about this trace? The tracing of line 4 in this case. Yep.
Yeah, can you repeat that? Sorry.
Yeah.
Okay.
That's a little bad.
Okay, so the operation, let me see if I can represent it in a slightly different way. Okay, I can do this on the whiteboard. All right, so let's take a look at line 4 on the whiteboard. Okay, so a bracket I plus 1 gets a bracket I plus I plus I plus 1. Okay. So the way I'm going to do this is I will kind of specify the order of operation by using, kind of like a reverse tree representation. The first thing we do is we evaluate what is inside the square brackets. So in this case, I has a value of 0. So that means we are actually accessing a bracket 0. A bracket 0, when you look up the column, is column D. Column D has a value of 0 itself, right? And then we can perform the addition. I is 0, I is 0, and then we have a plus 1 here. So when you add these 4 numbers into the sum, it has a sum of 1. That's the right-hand side. On the left-hand side, we first evaluate the stuff inside the square bracket just to find out which element am I trying to access in this case. I has a value of 0. 0 plus 1 is 1. Okay? So this 1 is now used in return in the square bracket operation, so it becomes a bracket 1. Okay? So a bracket 1 is referring to column E in this case, and that's why it is the whole thing becomes just a bracket 1, which is the specification of 1 column, getting a value of 1. So for those of you who want to take a picture or just write some notes, this would be a good time. Is that working out okay? Yep. Because I think a picture helps sometimes, just by showing you, the order of operation. All right. So after line 4, we have line 5, which is a very simple thing to do, just adding 1 to I. I goes from 0 to 1, and then we go back to line 3 again. I is now 1. 1 is less than 3 is true. Okay. And now we go back to line 4. Now, this really kind of helps to illustrate the flexibility because of the use of an array. Because with the use of an array, even though we are executing line 4 over and over again, but each time we execute line 4, a bracket I refers to a different element, and a bracket I plus 1 is also referring to a different element. So that's why it is so useful, because now by controlling the value of I can perform the same statement over and over again, but each time it is actually doing something different from the previous time. Okay. So this time when you look at this thing here, can I erase and redo this part here? Okay. So I'm going to do the same thing by writing out the values of each component. We evaluate stuff inside the square bracket first. So a bracket I is a bracket 1, because I has a value of 1. So this is a bracket 1. A bracket 1, if you look up the trace, has a value of 1 at this point. Okay. So we have 1 plus I itself is 1 as well. So these add up to 4. On the left-hand side, we also evaluate what is inside the square bracket first, which is I plus 1. I has a value of 1 at this point. 1 plus 1 is 2. Okay, so I'll do it really step by step. I has a value of 1. 1 plus 1 has a value of 2. So we are now trying to access a bracket 2. A bracket 2 gets a value of 4. Okay. I think most of you know what's going to happen in the in the last iteration too. So I goes from 0 to 1, excuse me, 1 to 2. Did I miss one? No, that's right. Get this right, okay. And then we go back to line 3. I is now 2. 2 is less than 3 is true. We go to line 4 again. Okay, we go to line 4 again. On line 4, a bracket I refers to a bracket 2. A bracket 2 has a value of 4. I itself is 2, so it becomes 4 plus 2 plus 2 plus 1, which is 9, okay? And what do we do with the right-hand side? We store it to the left-hand side. The left-hand side is a bracket I plus 1. I has a value of 2 at this point. 2 plus 1 is 3. So we are actually updating a bracket 3. A bracket 3 is column G, and that's the one that is getting a value of 9. Is that okay, or does anyone want me to use the whiteboard to illustrate this one? Is that okay? Because it's the same process. You evaluate what is I first, and then you evaluate the stuff inside the square bracket, and then you can work out the rest. Is that okay? Yep.
I'm messing something up in my head. I don't know, I'm getting 7. A bracket I plus I plus I plus 1.
Right, but I has a value of 2. Okay, a bracket I is a bracket 2, which has a
Oh, it's
value
4.
of 4.
Okay, that's
So
fine.
it's 4 plus 2 plus 2 plus 1, which is 9. So you, okay.
Yeah, I was counting A bracket I as 2 instead of
Yeah. It really helps to use a picture. So because I has a value of 2, so now this part becomes a bracket 2. I has a value of 2. I has a value of 2, but a bracket 2 has a value of 4. That's right. So I think that might be why you add up to the wrong value. 4 plus 2 plus 2 plus 1 is 9. On this side, I has a value of 2. 2 plus 1 is 3. So now we have a bracket 3 giving a value of 9. All right. And we add one more. We add one to variable I after this on line 5. I goes from 2 to 3. We go back to line 3. I is now 3. So is bar A bar minus 1. So the whole thing is false because 3 is not less than 3. And then we get out of the loop. We get to post. We're all done. So you can probably see that if I make this array like larger, the value that I store at a bracket n, whatever n is n squared. Right. Are there any questions about this particular algorithm? But does everybody start to see why arrays are useful? It has to do with the indexing operation, where you can use an expression to choose which column or which element in an array you want to access. That is why arrays are so useful. Okay, so with this out of the way, we can now start to think about search algorithms. Okay, so we are actually moving on to topic 6 now. Okay, topic 5 is done. 1 hour, we're done. So I want to kind of mention where we are at this point. We are done with topic 5. We are now moving on to topic 6.
Is there homework for this time?
Not yet. But thank you for the reminder.
Even begin.
Well, I kind of have to finish grading, the midterm first.
I like that.
Otherwise, I have a huge backlog of stuff to grade at the end of the semester. That's not good. It just takes me a long time to grade the exam. Take my time? Oh no. No, you guys need to get hands-on experience. Otherwise, you will start to forget the concepts.
We wouldn't want you to rush it and accidentally make a mistake. That'd be a shame.
Well, thank you for your kind consideration. All right. So let's think about the search algorithm. Okay. In the previous class, I did not have time to do this, but with this class, I do. So let's think about the search algorithm. Now, when we think about the search algorithm, we'll say, well, the question is, can you describe how to search for something in a systematic way so that we can actually put it into pseudocode? That's the question. And most people would not be able to do that. Well, that's because we are too smart. Okay, so let me give you an example. Let's pick up a phone book. Just imagine that you have a phone book. I know we don't use phone books anymore, but let's just say that we do. Okay, so you pick up a phone book and I say, look up Joseph Brown. Okay, last name is Brown, first name is Joseph on the phone book. Okay, how do you do it? How do you describe the systematic way of doing that? Well, you're not going to do it, right? You just kind of flip through the pages. I can kind of guess, where B starts. Okay, nope, not quite there yet. You'll go a little bit before that, and then once you get to the B's, then you can start to look for Brown. Not this page, not this page. Okay, now we have Brown, and then look for the first name Joseph, right? It's not very systematic, and to you it is, okay, but it's not actually very systematic. It has two reasons why it's not. Because one, the phone book is sorted. So you can basically say, okay, we have gone too far, we have to go back up a few pages. Two, you have heuristics, okay? In other words, you kind of know how names are arranged, how many names start with BA, how many names start with BE, and so on. So you can kind of guesstimate how many pages you have to flip in order to get to, quote unquote, the right page. But that's all non-systematic, okay? That's all heuristic, rules of thumb, basically. So to make it systematic, I can cast the problem in a slightly different way, and then you guys will have to use a very systematic way to do it. Instead of looking up a name in a phone book, I'm giving you a phone number. Find out who has that phone number.
Okay.
Wouldn't that make it a little bit more, challenging, and you cannot use the usual heuristics anymore?
But if
That is what it is. Yep.
okay, range by area code. Yeah.
I would just call the number.
Like, hello, who's
But
this?
that
You may
phone-
not know me, but
Yep.
what's your name?
But that's the kind of problem, okay? Because remember, every time we want to write an algorithm to do something, you have to first come up with a very systematic way to, you have to have a way that can be described. And this is what it is, okay? I give you the phone number, I give you a phone book, and you have to find out, first of all, whether that phone number is even in the phone book, and two, if so, who has that phone number. All right? So what is the systematic way of doing it?
You would have to
First-
start looking for the number, the next number, like all the way through.
Well, there are several ways that are quote-unquote systematic. Okay, you can pick up go ahead.
I was gonna say that you could make an array that has all of the phone numbers in the phone book as individual variable. Can't remember the term for it. But,
Elements.
Elements. There we go. And then from there you write an algorithm in which scans each one, like the way he was saying, for the, that phone number.
Okay, so there are different ways to scan it too. Okay, because when we talk about systematic, some people would come up with this logic. I'm going to have a highlighter. Okay, I'll just flip to a random page, pick a random row, and say, is that the number I'm looking for? Nope. Okay, highlight it. Close the phone book. Pick another random page. On the random page, pick a random phone number. Is that the phone number I'm looking for? No. Scratch
That
it.
actually would work eventually.
It will work eventually, but is it a systematic way?
No.
Is it any
Might
better
fall,
than
but
starting from the
very
beginning
deep
and then work your way forward?
It's probably worse.
It's probably worse because before you can actually find the phone number, the phone book will be so worn out that you can't really flip it anymore. It will just decompose and, Okay, so it's better to start from the beginning, just say, okay, we'll start from page 1, okay? And then use a ruler to help you, keep track of, okay, is that the number? No. Move on, next one, next one, next one, next one. Move on to the next page, and so on. Okay? All right. So let's see how we can describe that logic. I did not do this with the previous class. I probably should do it, like on Thursday, just so that they catch this concept. Okay, so how do we write that algorithm to find a particular value in an array? Okay, that is not sorted, okay? If it's sorted, it's different. Okay, so I'm going to label this to find a value in a unsorted array. Okay. Now, the other way to do this is really to use a spreadsheet, and we can say random times Q's number, and then we'll take the floor of this thing. The floor of something is really just
The least it could be.
is the largest integer that is less than or equal to that number. Okay. So the way I want to do this is I'm going to give you a humongous array, so you cannot use the eyeball algorithm. And I'll just say that I'm looking for the value of 3,000. Okay, I'm looking for 3,000 in these numbers. How do you do it?
Look at 298. Go from there.
Well, you can do it that way too. You can look at the first one. Not the number that I'm looking for. Look for the next one. Nope, 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 and then keep going, right? I would call that pretty systematic. Okay, and when do we terminate? When do we stop? I find 3,000,
Or you
or
don't.
Or you get to
or there's nothing else, right? I have gone through the entire array. Okay, very good. So I think we got the logic of doing it by hand. So let's see if we can kind of capture that logic in pseudocode. Would you call that method repetitive?
Yes.
Yes.
rather.
Okay, boringly so, right? All right, so we know we have a loop of some kind, and when do we get out of the loop?
When we find
We just
the,
mentioned that. We can just use the English. We don't have to use any notation.
when we find the number.
Okay.
Or we don't
When we
find
find
it.
number n.
Okay, when the item is found, or
Not found.
All the elements have been checked. Or
okay, or we can just say they confirmed the element or the item is not there. Okay, how's that?
Yeah.
So the item, not
Mhm.
items. Okay, there we go. All right. Well, even though it is really vague, it doesn't really say anything about the algorithm or the method of doing it. And we don't even refer to arrays or actual comparisons and stuff like that. This is still a useful first revision. Yep, go ahead.
Is this only like specifically the phone numbers and to say that no number can be repeated?
In this case, I just need to know whether it exists or not. So if it repeats, that's fine, but I need to know whether it has at least one occurrence in the phone book. Okay. All right. But even so, even though it is really vague, it doesn't use any type of actual code representation. It is still useful because I identify this is some kind of a loop. Okay. And then the second thing is I really kind of know, how I'm supposed to get out of the loop too. Even though it's really vague, it is still a good indication. So in the second iteration, what I'm going to do, this is revision 2, is I'm going to start to introduce terms like, variables and stuff like that. So we'll just say that, array A stores, stores values. Variable K stores the value that I am looking for. Okay. All right. So now let's take a look at the pseudocode here and see if we can at least find a way to clarify some of these statements here. When I say previously an item is found, what does it mean when I have array A storing, basically being the phone book, and variable K storing the phone number that I'm looking for? Doesn't it really say the same thing as, A bracket something, I don't know what to put inside the square brackets, is the same as K. Something in the array is the same as what I'm looking for. Okay. I don't really quite know how to express the second one, so I'm gonna leave it the way it is. Okay, it's gonna be it will still be kind of vague. And I'll call this revision 2. It's already a little bit better because now I'm starting to use array indexing, comparison. Okay. So in revision 3, I look at revision 2 and I say, well, that's really kind of vague and I don't really like to use a question mark inside the square bracket. In other words, I need to know how I'm going to specify the item that I'm comparing to with the value of K. And I use a variable in this case because I know that that is not always the same. Okay. So in this case, I'm going to use introduce variable I, as the index of the element to compare to. Okay, so I can now rewrite my subroutine, my pseudocode here a little bit, and just say that, hey, if the element that I'm looking at, which is specified by variable I, has a value of k, we can get out of the loop, right? Another revision. Now, revision 3 is significant because now I know, okay, I need to somehow control variable I so that as long as I have not found the value I'm looking for, and I cannot confirm the item is not in the entire array, I have to do something, move on and look up the next one, right? So using the analogy that we had before, using the spreadsheet, how did we go from one item to the next? Was it random?
I don't know. It was I+1.
I get I+1. Okay, we just keep going forward, right? Okay. So that means, somehow in the loop here, we just have to say, well, as long as I have not found what I'm looking for, and yet I'm not done with the entire array yet, just go ahead and move on. Okay, I gets I+1. Is that okay so far? Because if I don't change I and a bracket I does not equal to k, it will never change, right? So that means, inside the loop, I have to do something about I so that I keeps changing all the time, so that one, I can either find the item itself, or two, I can confirm that I have gone through the entire array and it's not there. Are we doing okay so far? Okay. So revision 4, is just introducing this particular element here and just say, okay, if I have not found it and there are more stuff in the array to look for, to search in, I need to increment variable I so I can just, in the next iteration, I'll be looking at the next item. Right. So now in revision 5, I'm going to say, but I need to start somewhere. Right? Because if you look at revision 4, I'm kind of counting on variable I to have some value to begin with. So maybe I should initialize I to something. Where should I start? 0 at the beginning of the entire array. There's no reason why I should start in the middle in this particular case. So I'm going to say, well, let's start with the beginning, and as long as I have not found what I'm looking for, and I have not searched through the entire array, move on to the next one, and then do the comparison again. Am I still doing okay so far with the progression of the logic here? Okay. All right. That is useful. Now this one is, revision 5 is, well, the combination of revision 4 and 5 is very useful because one tells me that I'm starting from the beginning with index 0. The other one is telling me that we just keep moving forward all the time, okay? +1, +1, +1, +1. But doesn't that tell me that, there's an easy way to tell whether I have gone through the entire array or not? How do I know that how do I replace this phrase here and say that, okay, we can probably get out by now because I have gone through the entire array and I still haven't found it? How do I express that? Using I and something about A.
Use an if-then statement?
Well, not an if-then statement, but a condition. What condition do I use to?
Bar A bar is less than I -1.
Okay, well, let's take a look. All right, so we know that I is involved here because I is the one that is moving. We know that bar A bar is also involved here because we know that it has to do with, we have to somehow relate I with the number of items in the array to decide, okay, we're done, okay, because we have just gone past the last item in the array. And I is controlling the index. So when do I know that I have gone past the end of the entire array? When I is, how should it relate to bar A bar? Okay, normally, what is the index of an element inside an array? It starts with 0 and it ends with bar A bar -1. Okay, bar A bar -1. So by the time I gets to bar A bar, I know I can get out. Because bar A bar itself, which is 3 in this example, is an invalid index. I don't have a coffee mug with a label 3. Is that making any sense? So in order for me to confirm the item is not there because I have gone through the entire array already, I can say that as soon as I is not less than bar A bar anymore, I can get out. Is that making any sense? Okay. All right. Okay, that's revision 6, which is actually the trickiest of all the revisions. Yep.
So why isn't it A bracket bar A minus 1 from the notes, which say like the notes you told us to read is like the last element is
Right.
A bracket.
That is true because
Or is
okay.
that just a bracket?
The notes is saying if you have an array A, then A bracket bar minus 1 close bracket is the last element in the array. That's because this tells us how many elements there are in the array, but the index of the last element is the number of elements minus 1. So this, in fact, the entire thing is the last element in the entire array.
So why are we using just I plus 2?
Because this is referring to the value of that element. I don't need to know the value of the element. I just need to know, have I gone past the end of the array? So I'm just looking at what would go into the square bracket operation and say that cannot exceed bar A bar. It cannot even be bar A bar or exceed it. Did I answer the question? Okay. All right, so we're almost done here, because we have everything almost in regular pseudocode notation. I get 0, we can do that. I gets I plus 1, we can do that. A bracket I equals K, we can do that. I is greater than or equal to bar A bar, we can do that too. So the only thing left is to decide, do we want to use a pre-checking loop or a post-checking loop? Okay, we can use a pre-checking loop. Whenever you have a choice, use a pre-checking loop. That's usually the preferred way of doing things. So I get 0, while something, do the following. I'll let you guys help me decide what to do inside the question mark here. Inside the parentheses. Okay, in the previous case, in revision 6, we specified the exit condition. But when we specify a while loop, we're specifying the stay in loop condition. So we have to negate the logic. To negate the logic, there are 2 ways to do it. The cheapest way to do it is to put a not. And then we just copy and paste it. And we're done. Not really the best way to do it, but it's one way to do it. Okay? So what we can do is now say, well, that really looks ugly. Okay, so we'll go ahead and refine it. All right. So if we say it is not, and remember the not is on the outside, the or is in the inside, that really is the same thing using DeMorgans Law. It's really the same thing as saying, not A bracket I equals K, and not I is greater than or equal to bar A bar. This is DeMorgans Law, transforming the expression. In other words, when you have a not on the outside, you have A or B in the inside. This is really equivalent to saying not A as one thing and not B as the other thing. Okay, this is DeMorgans Law. So we just apply that DeMorgans Law and turn it into like this. And from here, we can make it even better, because instead of putting the negation here and doing all kinds of stuff, that is kind of indirect, we can just, change the operator, change the comparison operator, so it becomes A bracket I does not equal to K, and the other one is just I is less than bar A bar. It looks a lot cleaner now. Great. Does it work? Well, we can throw it into a test case and see whether it works or not. Okay. So we'll go ahead and use sheet 6 for the algorithm, which is I gets 0, while while a bracket I does not equal to k, which is what we're looking for, and I is less than bar a bar, which means we're still within range. Do the following: I gets I plus 1, and while that's the entire algorithm. And I will promise you that we'll end today's lecture in a bad note, on a bad note, because we'll break it. We'll break the algorithm, and then we'll come back and fix it on Thursday. Okay, we got variable I, line number I, K, array A, and we'll just have 2 elements in this case, just so that we can get out of class in time. Array element A bracket 0 has a value of 4, this has a value of 5, and we're looking for the value, let's say 10, and I is initializing the algorithm, so we don't have to initialize it first. That's my precondition. And then you look at this code and go like, well, I don't really see a problem here. You will still get out of the loop because I is less than bar, a bar will eventually become false. Well, yes, but we'll have a problem first. Okay, so we'll take a look at the problem. We have enough time to get us into trouble, so that we'll end today's class with on a bad note. Cliffhanger, as they say. A bracket I does not equal to k. Okay, first of all, what is I? I is 0. So A bracket I is referring to A bracket 0. A bracket 0 has a value of 4. K has a value of 10. 4 is different from 10 is true. Not a problem. What about I is less than bar a bar? I is 0. Bar a bar is 2 in this case. 0 is less than 2 is true. True and true is true. Not a problem. Go to line 3. Add 1 to I. Go back to line 2. Reevaluate this. I is 1 in this case. A bracket 1 has a value of 5. 5 is different from k, which has a value of 10, is true.
Yes.
I is 1. 1 is less than 2 is also true. True and true is true. Not a problem. Okay, go to line 3. We add 1 to I. We go back to line 2. A bracket I is what the? It doesn't have an A bracket 2. So here comes several questions plus a cliffhanger for Thursday. First of all, what is the program going to do? If you write a program like this, exactly like this, what is the program going to do? The answer is it depends on the programming language. Okay? Okay, don't leave yet. We still have 2 minutes. We still have 2 minutes. Okay. First thing is in C and C++, it will look at column G and pretend that that is our A bracket 2, which is a very, very, very bad thing to do because it's just referring to somebody else's value and say that, we just pretend that's A bracket 2, not a problem. In PHP, Perl, and other scripting languages, it will basically say, I see that you would like to have A bracket 2 to exist. We'll make it happen. I'm making the array just 1 element bigger now, okay? Starting with an unknown value or an uninitialized value. In the case of Visual Basic, it will come up with a runtime error and say, you are accessing the array out of bound, which is the best thing to do in a scenario like this, okay? But the question now is, okay, we know this is going to be doing something wrong, okay? In all 3 cases, it's not what you want to happen. So the question is, how are we going to fix this problem? And that's the cliffhanger for Thursday. Yes? Go ahead. Sorry? Oh, I can say it. We reverse the order of the conjunction, and then we become lazy. So I'm teaching you guys really bad habits. Procrastination is good. Lazy is good too. Cliffhanger, Thursday.
Yeah. 9 o'clock.
We'll shoot.
That's right. There you go.
It's still done on the while loop.